All right, let's jump right into this explainer and see if we can decode the absolutely incredible, totally hidden world of animal communication that's literally happening right outside our windows. Every single day, we're surrounded by this complex, high-stakes exchange of information, this massive interspecies network that, honestly, most of us completely tune out. Well, today, we're going to crack that code.
So, have you ever actually wondered what birds are saying? When you hear those everyday chirps, the songs, maybe a sudden squawk in your backyard or at the local park? It's so easy to just dismiss it all as pleasant background noise or just random chatter. But what if I told you that these sounds are actually part of a highly evolved, incredibly precise, and dynamic communication system? A system where everyday survival literally depends on sending and interpreting the exact right message at exactly the right time.
Section 1. What are birds saying?
To understand exactly what's being said out there, let's zoom in on a very familiar and very vocal backyard resident, the black-capped chickadee. What's really fascinating here is how the specific vocabulary of the chickadee actually breaks down. They don't just have one generic chirp, right? They have very distinct vocalizations for completely different situations. For instance, they use a simple two-note phoebe song to attract a potential mate, or just to advertise their territory. Then you've got these quiet little contact calls, which they use to keep the whole flock together while they're foraging for food. But if an intruder gets a bit too close, the dominant bird is going to use this harsh territorial gargle sound. And finally, of course, there's the famous chick-a-dee-dee-dee call, which acts as their danger alarm. And the really crazy part? The meanings of these calls aren't static at all. They change dynamically based on the exact context and what the bird is currently doing.
Okay, moving on to Section 2, the anatomy of a signal. Before we dive deeper into how that alarm call actually works, we need to make a really crucial distinction between a mere cue and a true signal. So a cue is basically just accidental noise. Think of it like this. If a mouse is just going about its day, foraging in the grass, and an owl hears that grass rustling, well, the owl has received information. But the mouse definitely didn't rustle the grass to communicate with the owl, right? It was just a byproduct of moving around. A signal, on the other hand, is a highly evolved tool. It's a trait that has been specifically shaped by natural selection for the express purpose of altering the behavior of a receiver. The sender is actively producing a signal to influence another organism, and both the sender and the receiver are essentially evolving together in this back-and-forth exchange. And this brilliant classification really illustrates just how complex these signals can get through what's called multimodal communication. Basically, this means animals will combine different senses, like sound and sight, at the exact same time. Sometimes they use a redundant signal as kind of a fail-safe backup just to make sure the receiver gets the message even if they're in a super noisy environment. Or they can use non-redundant signals where the visual cue and the audio cue actually mean two entirely different things. This allows the animal to send multiple, highly complex messages all at once. Talk about multitasking. Which brings us to Section 3, decoding the alarm call. So now that we know what a true signal is, let's see this signaling theory in action. Because a chickadee doesn't just scream blindly into the void when it's scared. No, it follows a highly specific protocol. Step 1, it detects a nearby predator. Step 2, it emits a series of these really high-pitched C notes. And then, Step 3, it tacks on those D notes to the very end of the call. But here is the absolute genius part of the whole operation. The actual number of D notes directly translates to an escalating level of danger. So a low-threat predator, that might just get 1 or 2 Ds. But a highly dangerous, fast-moving predator, that could trigger 5, 10, or even more Ds. They are quite literally grading the severity of the threat in real time. There's also this totally remarkable acoustic physics trick happening here too. See, those high-pitched C notes at the start of the alarm call? Those are high-frequency waveforms. And high-frequency sounds travel incredibly well over very short distances, but they fade out rapidly because they get absorbed by all the leaves and branches in the forest. What this means in practice is that the chickadee can warn its nearby flock members about the danger without broadcasting its exact location to the predator. It's basically a localized stealth warning system. Let's look at Section 4, the interspecies warning network. Now, the absolutely crucial point to remember here is that these signals don't just stay isolated within one single species, not at all. They create this massive, forest-wide interspecies warning network, where totally different species are constantly eavesdropping on one another. Take the nuthatch, for example. When a nuthatch hears a chickadee's alarm call, it doesn't just blindly panic. It actually decodes the specific details of the signal.
Depending on the exact severity indicated by the chickadee's call, the nuthatch will accurately adjust its very own survival tactics. It might freeze, it might hide, or it might even fly right toward the chickadee to join a cooperative mobbing attack to try and drive the predator away. And it gets even better. Research shows that nuthatches will actually assess the reliability of the chickadee's call before they pass the warning on to others. It is just this incredibly intricate web of shared information. And we see this kind of cooperative survival strategy globally, not just in the backyard. For example, down in the Brazilian savanna, the white-banded tanager often acts as a quote-unquote sentinel. Basically, one bird perches way high up and keeps a lookout for predators while everyone else eats. Now, when these tanagers are only hanging out with their own species, their vigilance, how intense their lookout is incredibly high. But when they join up with a mixed species flock, their need to act as a sentinel drops significantly. By teaming up with other species, they're creating this many eyes effect, which drastically cuts down the time any single bird has to spend looking out for danger. And that, of course, leaves them way more time to forage and actually survive.
Finally, Section 5, the human language continuum. For our final zoom out in this explainer, let's explore how this wild interspecies survival network actually provides us with some really profound clues about our very own evolution. In a recent, totally groundbreaking study, scientists discovered something that is just astounding. 21 different bird species globally share a nearly identical universal word. They all produce the exact same whining vocalization to warn specifically against brood parasites. Now, if you don't know, brood parasites are birds like cuckoos that'll literally sneak into other birds' nests, lay their own eggs, and force the poor host birds to raise their destructive young.
Now, for the longest time, biologists have debated the strict definition of communication. They wondered whether animal signals carry actual, real information in the same way human language does. I mean, for decades, many just assumed animal calls were basically just instinctive gasps of fear. But this cuckoo discovery completely challenges that sharp dividing line, because these 21 species, they are associating a specific learned sound with a highly specific external threat. It's a referential call. They are quite literally naming an object in their environment. And what makes this even more mind-blowing is that some of these 21 species haven't shared a common ancestor in over 50 million years. 50 million! They live thousands of miles apart, from Sweden to Zambia to China. This shared language evolved purely through the mutual pressing threat of these parasites. I mean, if a bird lives in an area without cuckoos, it doesn't make the call. But if they're exposed to the threat, they learn it. It represents this incredible midpoint between raw instinct and a fully learned vocabulary.
Which brings us right to this powerful quote from behavioral ecologist Rob Magrath. Listen to this. Animal communication and human language appear to be on a continuum rather than language being a uniquely human feature. You know, way back in 1871, Charles Darwin hypothesized that human spoken language likely originated from these exact kinds of instinctive animal sounds and alarm calls, which our early ancestors then learned to imitate and modify to reference specific things. Well, over 150 years later, it looks an awful lot like Darwin hit the nail right on the head. Which leaves us with this final kind of wild thought. If a simple bird's alarm call really is the evolutionary seed of human words, what other complex conversations are we entirely missing out in the wild? The next time you step outside and hear all that chatter up in the trees, just remember, you aren't just hearing background noise. You're actually listening in on a millions of years old survival network, and perhaps hearing the very echoes of our own origins. Thanks for joining me on this explainer, and definitely keep your ears open out there.